Welcome to the Profiled Corner. Today's video is part 5 in the Introduction to Woodworking Routers series. This is the second part of creating trays using routers. In the last video, we encountered a few problems. Some of these I caused myself somewhat intentionally, and others were caused by the equipment. First of all, the router that I was using, which was purchased at the end of December of last year, has a sticky plunge mechanism. I don't know if I can demonstrate it or not. I have it here in front of me. Anyway, when it's released, it sometimes sticks partway through, and also when you're plunging down, sometimes you'll get resistance thinking that it's all the way down into the cut, and you move the router and you're only cutting air. You may have noticed that in the video that I was cutting air at times, and then I noticed it and I dropped it down a little bit further. And then when I was trying to get it out of the cut, I pulled the lever here, and the base plate did not come up all the way. The router did not come up all the way out of the cut, and I ended up nicking the template that I had created. So that's undesirable. I'm hoping that this router breaks itself in so that it works as well as my other Bosch 1617 EVS plunge router that I bought used. That one seems to be working pretty well. I've got that one back here, and we'll be talking about that in a couple of minutes. Okay, so I had a problem with the router. I was also taking too heavy of a cut. The bit that I was using, which is a bowl bit, has a 5/8 inch cutting depth, and I was attempting to take a full 1/2 inch cutting depth with it. What I should have done is to take a 1/4 inch cut on the first pass, and then make a second pass at a 1/2 inch deep. And that would have made it so that there was less stress on the router and less stress on myself in moving the router around. So that was the second problem. The third problem is that I had insufficient support for the base of the router at times, and that caused two dips to develop in the tray that I was cutting. I should have stopped and put a different base plate on the router. I have a couple examples of router base plates in front of me that we'll look at in just a minute. I had the incorrect balance of double-sided tape holding the template down to the wood. I was correct about 87% of the time, and unfortunately I used far too much double-sided tape on one segment of the template, and when I tried to remove that template, it actually pulled apart the tray. I'll insert a video clip showing the result of that. I ended up having to use a heat gun to remove that double-sided tape from the plate that I was creating. Turns out the double-sided tape is stronger than the wood itself. I couldn't remove the portion of the template and ended up splitting the bottom of the tray. Oh well, this is a fun little project. The tray re-glued. It's not perfect. I still have, well, I had a little window here. I'll show you a close-up view of this before it was glued up again. There was a little window I could see all the way through right here. Unfortunately, after I glued this up, I found the little piece of wood that should have gone into there. I wasn't able to push it all the way into the hole, so I'll have to take care of that with a router. And also, I've got some roughness up in here that we'll have to take care of. So we can take care of that in a couple minutes. I want to show you some different options for base plates that could have been used to keep the router from diving in to this area right here, and also right in here. And it dove in because I didn't have enough support with the base plate of the router. Okay, so one thing that you can do is if you have an extra piece of plywood, this is 1/2 inch thick plywood, you could drill holes into this and a center hole, and you can mount that to your router and use that as a large base plate. The disadvantage of this is that this is not transparent. You can't just see through it, so it makes it a little bit hard to make sure that you're cutting in the right spot. One of the other things that you can do is to create a base plate using plexiglass or acrylic. This is one that I built. This plexiglass is about 12 inches by 24 inches and almost 3/8 inch thick. It was still way too flexible, so what I did was I added some 1.5 by 1.5 boards to stiffen it up. And one of the things that this will let me do is to attach onto the front of here a circle cutting jig that I will make later on. Or it could also potentially cut ovals if I choose to go that direction with it. I'll insert a couple of video clips of me building this. I built a portion of it using the PantoRouter, specifically the mortise and tenon joints that are used to connect these pieces here. So I'll insert a couple of video clips showing the build process of this jig. This jig, the plastic was about $35, so it's a little bit more expensive than the plywood, but it may be a good option for you. Center the sub base on the piece of plastic and mark the locations of the screw holes. Use a punch to leave a mark in the plastic so that a drill bit will be able to drill through that location without sliding. Use a small diameter drill bit to create a pilot hole for the screw holes. The pilot hole should be smaller in diameter than the screw. The pilot hole will be enlarged later. Use a drill index to determine the correct size for the pilot hole for the screw. In the case of my Bosch 1617 EVS plunge base, it appears that I need a 5/32 drill bit to allow the screw to easily pass through. Drill a suitably large center hole using a large drill bit. I'm using a 2 1/8 inch drill bit. I have a pilot hole already drilled into the center for the bit to drop through. Be certain to drill the hole in the center from both sides so that there's no blowout on the back side. Next, you need to create countersinks on the bottom side of the sub base for the screws. Here's the structure that I plan to use to stiffen up the plexiglass. I'll be cutting mortise and tenon joints at the PantoRouter to put this together. I've used the actual side piece here so that the mortise will be centered in the board. I've got down here a 1-2-3 block used to set the depth of cut to just over 1 inch. I'm using the table stops on the front of the table so that the board to be mortised will be lined up with the front of the table. And I have the 1 inch wide template for mortising set up in the PantoRouter. So now we're ready to cut a mortise that is just over 1 inch deep, 1/2 inch wide, and 1 inch long. mortises are cut, now we need to cut the tenons that'll go into the mortises. Now, I've used a 1-inch setup block to set the depth of cut. I've used the swing stop on the PantoRouter to set a known depth in which this extends beyond the end of the table so that I can repeat that depth of cut on the other end and also on the other board that I've got to do. So I'll move the swing stop out of the way so it doesn't cause any problems. I have a 22 millimeter guide bearing installed about halfway from the back of the template holder to the front of the template. That's about the right location for cutting a mortise. And I can confirm that just by moving the bit, and I can see that the top of this 1/2-inch router bit is actually just below the surface, so I actually need to pull that bit back ever so slightly to make the cut a little bit less aggressive on the first time. Alright, we're ready to go. It's the right thickness. Okay, it is ever so slightly too thick. And that's what I want on the first test. And so now to fix that, just move it a little bit further down the template, a little bit further away from the template holder. Looks like that's going to be a nice tight fit, maybe ever so slightly too tight. Yeah, it's ever so slightly too tight for glue to fit into there. So I'll do it one more time here. Move it out ever so slightly. Okay, that's a nice fit. Now I can do the other 3 tenons. mortise and tenons are now cut on the PantoRouter, so now we're ready to assemble. Another option is to use a Rousseau base plate that's designed for a router table. This is roughly 9 inches by 12 inches. I bought this one somewhere around 2002 or 2003. I actually bought 3 of these. I used one of these to mount a Milwaukee router to my router table. And then I bought 2 others that I could use as spares in case that one gets broken. So I've got 2 more of these. And I have not used this one yet. It does come with a starter pen, but you wouldn't really use that with a handheld. And you'd have to drill your own holes. I don't believe that this is sold on Amazon anymore. However, I did check Rousseau's website this morning, and it is still listed as a product on their website that can be purchased for roughly $50 if I remember correctly. So this is another option for you. It's 9 by 12, and that should be large enough to provide support for at least this tray that I built. Another option is something called the Ultimate Router Base. This has pre-drilled holes to mount a variety of different routers, including this Milwaukee 1 3/4 horsepower router, as well as the 2 1/4 horsepower Bosch 1617 router, as well as a number of different routers. I've got this advertisement here that was included in the packaging that lists off all the different types of routers that are supported. And apparently there's a few additionals that are also supported if you go to their website. I picked this up just recently. I don't know how good it is. However, it is the perfect size for the tray that we're working on. So I have it mounted to the Milwaukee router so I can take a 1/4 inch radius roundover bit all around in here after I take care of flattening the bottoms of these pockets, because they are still a little bit rough from the process that we went through in the last video. So I'll take care of flattening the bottoms here first, and then we'll work on rounding over the tray. I have a 1 inch diameter spoil board surfacing bit mounted in the router. This router, for some reason, when it goes all the way down, it has a tendency to come back up a little bit on its own. So I got to make sure that I push this lever over to fully lock it in. So this is another Bosch 1617 EVS router. This one has a smoother plunging action than the one that we used in the last video. Okay, so I'm going to freehand route this. it would help if there was a light down inside there. It's a little bit hard to see where you're going without a light. And unfortunately, this router, as I mentioned, it seems to back off when it's at full depth of cut. And leaves a little bit of a rough edge. So what I'll have to do is I'll have to come back and sand that, or try to sand it out anyway, and see if I can make it look a little bit nicer. Camera, I mounted the other Bosch 1617 router, this is the newer one, into the base plate that I created. And I've been using that to kind of clean up the bottom of each of these pockets. This one does not automatically come up slightly when the lever is released like the older one does at full depth. And so that's made it so that I'm able to clean this up a little bit. And now I'm just using a fine detail sander down inside here to kind of clean up all the little burn marks and the little ridges that are still left over. I'm having trouble getting a round over bit to fit down in here because the bottom stud on the bearing is touching the base down here on the inside of these pockets. I wasn't anticipating that with these 1/2 inch deep pockets. That is a problem even for the most shallow radius roundover bit that I have. That's a problem. So maybe what I'll do is I'll just round this over by hand, and then I can round over the outside edges of this tray using the router bit. So I'm going to work on the center of the tray here with the sander. I have finished sanding the bottom of the tray. Now I'm ready to route the edge profile. I've switched from a 1/4 inch radius roundover to a 3/8 inch radius roundover in the router. And let's get started here and route this. I've got bench cookies on the bench here to raise it up off the table so that the bearing does not strike the table. I want to start on the end grain first and then work my way around. And that worked out pretty nicely with that ultimate router base plate. So now we just need to put some food safe finish onto this. After I blow it off, there's dust on it obviously. I found some food safe finish at Lowe's. This has mineral oil, carnauba wax, and beeswax in it. It's food safe, and so I'll shake this up real good, and then apply a bit of it, and then I'll bring the camera back. Remember, every unexpected bump in this platter has a story behind it. That's all for today. Thanks for watching. Bye.